Let's take a look at how oxidation numbers can help us show electron transfer. First of all, remember that an increase in oxidation number corresponds to a loss of electrons, which is oxidation. Remember, LEO, losing electrons, oxidation. A decrease in oxidation number means that the substance has gained electrons. It has been reduced. Remember, gaining electrons is reduction. So if we look at our first example and assign oxidation numbers, it's just a two-element compound, so we can just look at what column they're in. Potassium is the first group, so it's got a +1. Bromine is in group 7, so it has a -1. When we go over here to KBr4, we know potassium is +1 from being in group 1. Oxygen is always a -2 unless it's in a peroxide. So then we can figure out bromine because the whole molecule has to add up to give you no charge. So we have a +1 from potassium and a -8 because we have 4 oxygens. So then by doing the algebra there, we can see that bromine has to be a +7 oxidation state. So now we can use a bracket to show electron transfer. We can see here that bromine is the only substance that has a change in oxidation number. It goes from a -1 to a +7. The only way to do that is to lose electrons. Losing electrons is oxidation. To go from a -1 to a +7, bromine had to lose 8 electrons. So the next example, we can look at an ion table and see that hydroxide is OH- and chromium is +3. It could also be +2. So which one do we have in either one of these cases that have chromium? Well, let's use the crossing the charges method. So if we have 3 OHs and it's OH-, well, that means chromium must be 3+. So the oxidation number of chromium would be 3+. Same over here, since we have 2 hydroxides, we know the chromium on the product side must be chromium 2+. We know hydroxide is -1, and oxygen is always -2, and hydrogen is always +1, except for those few exceptions. So the only thing changing oxidation state here is chromium. It's going from a +3 to a +2. Its oxidation number is reducing. It's getting smaller. It's decreasing. So this is reduction, and this shows chromium losing 1 electron. Next two examples are a little different, but first of all, let's assign oxidation numbers. Br2 is bromine in its elemental form, so it has an oxidation number of 0. We can find out what bromine's oxidation state would be in the product there. We know hydrogen's a +1 and oxygen's a -2. The whole molecule must have a 0 overall oxidation charge, so oxygen has a -6 because there's 3 of them. Hydrogen's +1, so do the algebra, we can see that bromine's a +5. We can see that bromine is changing its oxidation state. It is going from a 0 to a +5. It's increasing its oxidation number. It is being oxidized. However, before we can determine how many electrons are lost, we have to account for the fact that the substance being oxidized or reduced is not balanced. We have to balance it first. So if we have 2 bromines on the reactant side, we have to have 2 bromines on the product side. So now, if you just look at 1 bromine atom, it is losing 5 electrons. But since it happens twice, we have a total loss of 10 electrons. We're going to see a similar occurrence in the next example with iron. Iron has 2 oxidation states, +2 and +3. Sulfate ion is always a -2. So I hope you can see here, if we cross our charges, SO4 is going to be a 2-, and in the case of the product, it is going to be iron +3. And the reactant side, that is iron 2, because it needed 1 iron to balance the -2 charge on the sulfate, so it must have been iron 2+. Oxygen is always a -2, and one thing to just keep in mind is that sulfur in SO4 2- is always a +6 oxidation state. If you just remember that, you don't have to figure it out so much. So here you can see iron changes from a +2 oxidation state to a +3 oxidation state. The oxidation number is increasing, so it is being oxidized. However, we have to account for the fact that the ions are not balanced. So we have to put a 2 on the side of the reactants to balance the ions first. Each iron is losing 1 electron, but we have 2 ions involved, so the total oxidation involves a loss of 2 electrons. I want you to try these 2 here. Okay, don't worry about doing this one, but try these 2 here on your own. Pause the video. When you think you got it and you can show the oxidation or reduction, press play and check your work. So those were a couple harder examples. So you should feel pretty good if you were able to do those on your own.